Hello. Today we are going to be talking about endothermic versus exothermic reactions. As we work through this lesson, I would like you to keep the two reactions that you performed prior to this lesson in mind. First, we're going to talk about chemical reactions and energy. So as you know, all of the matter around us is held together by chemical bonds, which are simply attractions between the atoms. Now, inside of those chemical bonds, energy is stored. Now, in order for those bonds to be broken, it requires energy, meaning to break those bonds, energy gets used up or absorbed by the reaction. This is absorbed in the form of thermal or heat energy, which causes a decrease in the temperature. So again, in order to break the chemical bonds, in order for the reaction to happen, energy must be used. This energy is going to be absorbed in the form of heat, which causes a decrease in temperature. When new bonds are formed at the end of the reaction, energy is released. The energy is released in the form of thermal energy, which causes the inverse, an increase in temperature. So if we think about the progress of a chemical reaction and how energy relates to it, the first step, as you know, is that the bonds of the reactants must be broken. This, again, involves an absorption or a using up of energy and a decrease in temperature. The second step in the progress of a chemical reaction is the reforming of bonds. When this occurs, energy is released in the form of thermal energy, which produces an increase in temperature. So with all of that in mind, let's talk about what an endothermic and an exothermic reaction is. So if a chemical reaction absorbs more energy than it releases, or it uses up more energy than it releases, we call that an endothermic reaction. Endo meaning into or inside, which is a nice context clue, thinking that energy is being overall absorbed in that reaction. This means that in endothermic reactions, more energy is used than is released. This results in an overall or a net decrease in temperature. On the other hand, if a reaction involves more energy being released than is being used or absorbed, we call that an exothermic reaction. If you think of the prefix exo, meaning out or outside, more energy is being put off. These reactions release more energy than they use up or they absorb. This results in an overall or a net increase in temperature. So an analogy that I like to use to sort of make this a little bit more simple is if you simply think about a bank account. So if you were to put more money into your bank account than you were to take out of it over a month, you would see an overall or a net increase in temperature. This is like an exothermic reaction. More energy is released than is used up in the process of the reaction, causing a net or an overall increase in the temperature. On the other hand, if I were to withdraw or take out more money from my account than I put into it, I would see that bank account balance decrease. That is like an endothermic reaction. I am using up more energy to make the reaction happen than I am releasing, overall resulting in a net decrease or a lowering of the temperature. So as you will shortly see in this unit, you all are going to be designing a device that involves thermal energy transfer and exothermic and endothermic reactions. So before we finish up today, we're going to talk about thermal energy transfer and how it takes place. So thermal energy, which we now know is involved in exothermic and endothermic reactions, either being released or absorbed over the course of the reaction. is transferred through heat. So you guys say this all the time. You heat things up, you've touched something cold, you've left something out in the warm and seen it heat up. Simply, the transfer of energy takes place through the transfer of heat. Now, heat transfer will only take place when there is a temperature gradient. That's just a fancy word that means a difference in temperature between two areas, meaning simply that one area is warmer at a higher temperature than another area. Heat will always, with no exception, travel from the area of higher temperature to the area of lower temperature. You will never see heat travel from lower temperature area to a higher temperature area. It simply does not happen that way. Now, this transfer of heat or thermal energy will continue to happen from the area of higher temperature to the area of lower temperature until equilibrium is reached. Equilibrium simply means that the temperature is exactly equal across both areas.